Hey guys, this is a friend Mainav from Civil Center and I welcome all of you back to our channel another video on Tekla Structural Designer. So friends, in today's video we'll model a particular S plus 3 building in Tekla Structural Designer. So these are the requirements which you have. Floor to floor height is 11 feet and these are the requirements which you have, and the stilt floor is totally used for the parking purpose, and here we have the first floor and here we have the second floor. The special feature of this particular building is that we can't give any columns inside, so we have placed all the columns along the periphery so that the parking of this particular steel floor is smooth. So let's start the particular modeling of this structure in the Tekla Structural Designer software. So we'll open a new file here. So we'll just click on new, and then a new file will open, and after that we'll process the steps. So first of all we'll go to model, and then in the model we'll go to construction levels. In the construction levels we'll create the construction levels, insert below, we'll give this minus this one, just select 1.2 meters, 1.2 meters, and here we'll just insert a level above it. Let's do this as SSL. Let's give the slab thickness of your 100, and then give this spacing of 11 feet. So 11 feet, if you convert it, 11 divided by 3.28 to meters, it will be 3.35. and then this is S, and then S plus 3. So we'll have insert 3 more levels above it, 1 2 3. So this is the S plus 3 building. All the levels have been done, and now we'll just click on OK. So at the base we'll just import the particular DXF file from the location which we have created. So we have created two center lines, one for the first floor and one for the second floor. So for the steel floor also we'll go with the one with the first floor. So we'll just open this first floor center line, and first of all we'll just need only the center line, and it will insert as an architectural grid. Unit is and then click on next, and then by layer, and we'll insert this in all the levels, and then click on finish. And after that this will appear here, and after that we'll just, if the grids are not visible, we'll just select the grids, and we'll just change the color of the grids here. We'll change it to black. Now the grids are okay. We'll just go again, import DXF first floor center line, and this time we will just import the shadow finish. So here is our plinth level for our stilt floor. So we know where to place the particular columns, and we'll place the columns accordingly, and we'll proceed forward. So this is the first floor beam column plan. So first of all we'll define a column size. Let's go to this particular column, and first of all we'll define a column size here. Let's define a column size here of, let's say, 350 into 250. We'll start with this particular column size, and then click on OK. Automatic alignment will turn it off, and then the grade of concrete will be, the grade of steel will be Fe500, grade of concrete will be M20. So now we'll insert it in the locations which you want. This is the first location, and this is the second location, and you can check the locations and insert the particular. Here we have one, and another one here as well, another one below. So in this line, one here, and then here in the toilet portion we have one, and at the last we'll have one. We placed this columns, and on this side we'll have this. As you can see, we'll start from the top. So we have inserted these two, another one will be in this partition. So, and the next three walls will have the 3, 1 2 and 3. So as you can see, we have not placed any columns inside, as this was the requirement for the stilt floor. So there are no columns inside. So after that, we'll simply go to the beams here, and this will be our beams for the plinth level. You can see in the structure 3 the columns are ready. Now we are going for the beams of the plinth level. So for the plinth level, let's go for beams of 250 to 300, and this will be our beam size, and we'll go this with FE 500, and then after that we'll just save this. Let's save this as 250 cross 350, or 300, sorry, 300, and then we'll apply. Since this will be the stilt level, we'll have only the beams, secondary beams for the staircase portion. So we'll click here, and then we'll click here. You can change the particular releases by simply double clicking on it. Releases, and then we'll go to left. As you can see, the left is the end one, left end one is pin, and end 2 we have a column here, so it is fixed. This beam, both are pinned, and this one, left one, that is the will be pin, and right one will be fixed, or both are particular pin, because we don't have any column here. So after doing this, we'll go to the beam, select the property set which we want to assign, and we'll just simply proceed with beams along the boundary here. This is the stilt level. Go for the validation is okay. So as you can see, this is our plinth level, which will be our stilt floor. So this is done properly, and as you can see here, this is done. And after that, we can go for this particular next floor. So for the next floor, we'll go to structure 3D here, and then we'll just go to construction levels, or we can just go to structures, levels, structure 1. So this is our ground floor. So we'll import the DXF file for our first floor. Open. Now we want a shadow, and then finish. We'll just zoom it in, and we'll just place our columns and beams. So first of all, we'll just go for our secondary beams, and then we'll go for our primary beams. So we'll take the particular this size, but here we'll take a larger size. Let's go with 250 into 350 for this, or let's go with 250 into, okay, first of all let's go to 350. After that, if it's not passed, then we'll go for the higher size. So for this, let's give a beam from here to here, and another beam from here to here, another one from here to here. This will be a primary beam. This beam we can consider later, because this is a very short span. So this particular staircase portion, let's consider this full beam. Let's consider this let's consider, and this one also will be a primary beam, full primary beam. And here, let's see if we can need to give any secondary beams. I think we're good here. And if this beam goes, this will also be a secondary beam here, and we can simply give the beams from here to here. And this one is not large span, so we'll not give it here, and this one will go, okay. So we have assigned most of the secondary beams here. So let's check it with the releases here, and for the releases, let's just give this, both will be pin, This one also both will be pinned. For this one also both will be pinned. This one also both will be, first one will be fixed because you have a column here, second one will be pinned. And for this one both are pinned. The first one is the sequence is from left to right and from the bottom to top. So as you can see, this for this one the bottom is this one, it is pinned, no column. This one top, so there is this end 2, this is also pinned, no column. For this one the end one will be the left one, end 2 will be the right one. So in both of them we don't have any columns, so we'll just do this as you can check here, we have a column here. So the end one will be fully pinned and this one will be fully fixed because you have a column here. So here we don't have any column, so both the particular releases will be pinned. Then click on OK, and then after that we'll go for the main beams. So we'll just select the beams here, and this particular size, let's just increase the size. Let's just do this as 300 into 450. Let's go with this size, and assign the primary beams. Now we have to check for some overlaps here, and the overlaps will just modify the validation. And for this member it will be supported later, but we'll check for the member intersection. This one, okay, for this one we'll just check for the member intersection, and if we have the coordinates or the free points, then we can easily do that. We'll go to edit free points, and after clicking on it we'll have this point and just move it here, and then as you can see this particular error will be avoided, and member may not be supported. We need to go to the beams, and we can give more number of this 250 to 350 primary beams, as we need to give a beam here, and this one we had missed, and this one also, this two beams, primary beams, we need to give. Just click on it and click on this as well. So if you validate, if you just change the member intersection one, so this one, let's fix the member intersection. For this, as you can see, sometimes you don't find the nodes, so then you need to go to edit, and then you can go to this 3 points and then OK, and then the node will reappear, or you can just click on add also, if sometimes this, and delete it, and sometimes nodes reappears. So go to home and then go to structure and then select this node reappears, and just put it one node here and one node put it here. So now if you just check, and again for this also this is okay, for this also put one node here. If you check the validity right now it's okay. We don't have a member intersection problems right now, and we have also, if you check in the structure 3D, we've also assigned all beams. So the beam assigning part is okay. Now for the next part, let's go with the next floor. So that is the second floor. We'll go to structure, go to the next floor, and then we'll just go to model and then import the DXF, and after import DXF second floor center line, we'll just open the second floor center line here, and we don't want the center line here, shadow, and then and then finish. So here we have the particular shadows made, and this beams will assign beam will take, and first of all let's go with 250 to 300 one, and If there are any internal beams, we can just assign them. This beam will go up to this. This beam should have had a center line. We had there was some error in omission of this particular beam. So what can we do? We can go back and make that, or else we can also, what can we do here, go to the 3D view and just, as you can see, we have this particular level. We'll copy this, we can copy this beam later from one level to another, so we'll do that later. So then I will skip this particular beam, and this one will be whole beam. This one will be from here to here, and this one will be, actually this one can be from here to here, and this one will be the whole beam, and this one can be from here, starting from here to here, and this can be a secondary beam here up to this much, and this one also for the staircase, this can be a secondary beam of this much. And for the remaining beams, so let's do it for the remaining beams. We have also already assigned the secondary beams, so this, let's keep this as 250 to 350 and save this property set 250 cross 350, or else we'll go with 250 to 450 as we had gone in the previous case. So it will name this 250 cross 450 for the primary, and after that we'll just assign the primary beams like this. And before assigning the primary beams, you can just click on escape, and you can change the support conditions of it, and this releases, as you can see, this is the end, this is the particular end one, this is the end 2, end 1 will be fixed, and sorry, end 1 will be pinned and end 2 will be fixed. Okay, so for this one, this we don't have any column, this one we don't have any column, so let's insert, fix the node beforehand. Now for this one, we'll just go to releases and maximize this, as you can see here. So we have made two spans here, so go to the releases here. For the span 1, both are pinned, and span 2, this is also pinned, because span 2, this is also pinned, both ends are pinned here. And for this particular span, this is the left is end 1 which is pinned, end 2 we have a column, so it's fixed. For this one, if we just divide this into some parts, this one will have one part here and this one will have one part here, so we divided this into spans. So this entirety, we don't have any columns, so all the particular spans, releases span 1 pin, span 2 continuous, span 3 pin. Okay, now this one we don't have any columns here, so if you can check, don't have any columns here, so we'll just do both of them as pin, releases pin. Okay, so it's important to check whether if you have missed anything. As you can see here, this end 1 will be, left one will be pin, right one we have a column, so it is fixed. So like this we can do, and after we have done it, we'll just go to this beams and then take our particular option of the primary beams 250 to 450, and then simply join this particular beams, primary beams. So while you are in the act of joining this, you can go to the 3D view, and here this particular beam we want, and you can go to edit, you can go to your particular option of copy, and just take this as the reference point and then copy it from here to here, then click on OK, because we might need them later. Go to structure 2, and we'll check the so it is, as you can see, this is not in the same line, it is in the different line, that's why the center line difference came. So what we can do, we can delete this, and we can continue with the model part, and then we can go take a parallel quick line, and let's take a line from here and approximately place it at the center, just for knowing what will be the particular zone in which it will be applied. So we made the center line. Now we'll go to beams and then take a 250 to 301 and make this particular beam, and then click on it. Releases end 1 and end 2 both will be pinned here, pin and pin. Okay, and after that we'll go back to the beams here, and we'll take our property for our primary beams, and then just assign our primary beams here along this end and along this end. So we'll check with the primary beams whether we have any intersection problem here. We shouldn't have. Now as you can see, we don't have any problem of intersection in this, so we are good with it. And as you can see in the structure 3D, we have completed our first floor and second floor. So we'll go to the first floor and we'll assign some slabs. For assigning our slabs, we'll go to this particular slab on beams option and then assign our slabs accordingly. This sparing the staircase portion will assign slabs everywhere. Now in the second floor as well, we'll assign slab. We're not actually looking at two-way slabs and one-way slab, because anyway in Tekla Structural Designer we can't design one-way slab, so there is no point of assigning one-way slab in the model anyway. So just validate the model and it's okay, good to go. And for the remaining floors, remaining two floors, we'll give the same particular design as this particular floor. So we'll just go to, this is S plus 1, S plus 2 is done. So we'll go to construction levels here. So this is in this source, we'll just make this as a 2 and this also 2. So here we have done. We'll just check the requirements once again. The requirements of this particular floor was S plus 3. So S plus 2 they are making already. So we'll have one more floor above it, and what we have given is, this is the basement, which is the S, and this is the particular 4th floor, and we'll just click on OK, and this is actually S plus 2 and one more floor above it, this is S plus 3. So we have made our S plus 3 building. We'll just validate the model. The model is okay and good to go. So the next step is application of the loading. So the loading parts you can apply as per the standard codes, and then which will apply it right now. So as you can see, the masonry material, let's check what is the masonry material which they are using. So it's fly ash brick which they are using right now. So for that, let's go to the loading part, and after that we'll start assigning our loads. So first of all, let's go to the particular plinth level, and then we'll go to the load, dead load, and after going dead load, take the full UDL and assign the loads for the 10-inch walls. All the walls here are the 10-inch walls, so we'll assign the loads here for that. This is the steel level is done. Next floor, let's go here, and first of all I want to go to scene content and just turn off the slab from here, and after that we'll go to load, take the dead load and full UDL 11 kilonewton per meter, and assign the particular loads. Here this is the staircase, so it will be 10-inch wall load everywhere. So here is the balcony here, so we have to carefully assign the portion. As you can see, this is the first floor plan. If you can check here, this is the balcony, so we'll have a wall here, so this will be a 5-inch wall, and this up to this much will be a 10-inch wall. So we can simply delete this entire thing will be deleted, or in this place Ctrl plus Z, and then change this to 5.5 and go back to this 2D. And if you want to insert a load here you can insert a load of 2 for some railings and all. This load you can insert, and for the remaining portion, so this portion also you need to assign 11. So we'll go to UTL and then 11, and then set the direction from here, and then select this and select this. So 11 kilonewton load have been assigned. So we go to UTL once again, 5 point, let's go take 5.5, select the directions from here to here, so like that. Now go to full UDL and 5.5 we are good to go. Just select all the internal walls and give this wall load of 5.5, and then we'll go to level load, and then residential building 2 kilonewton level load will assign. Scene content will just turn on the slab items and then pick the slab items here, and after that you can check it in 3D view. Turn on the dead loads. Dead loads have been assigned. Turn on the imposed loads. As you can see, imposed loads. So we had assigned the imposed load and the dead load itself, so it was an error. So we'll just select the, go to 3D view and just select this and delete this. And after this is deleted, just go to 3D view back again and then make this imposed load, level load 2 kilonewton per meter square. Pick this sub item, check it. So the level load has been assigned. After that we'll go back to the structure 3D. Next level, let's go, that is the structure 2, and in the structure 2 level let's simply insert some particular loads here. Go to scene content and then just turn off the slab items here, and after turning on the slab items we'll just insert the particular loads. So dead load, let's select full UDL and then 11 kilonewton per meter, and let's apply it for the external walls which we have, and for this portion, and for this portion, and for this and for this portion we'll just do take the full UDL. Here we'll go 5.5 for the 5-inch walls, and here this is 5.5, this is also 5.5. so these are all the internal walls which have been applied. Now this is remaining, this will be 2. Just take this, and for the parapet walls, for this one we'll just take UDL. As you can see, you can just take UDL and set the direction here and take it from here to, just change the value, this will be 11, and then set the direction, take it from here to here, and after that take UDL once again, take 5.5, and you can set the direction from here, select. So this loadings have been applied, and after that go to scene content, and before that just change it to imposed load. Go to scene content, turn on the slab items, go to your level load, take the 2 kilonewton per meter square, and just click on it, go to the structure 3D, and as you can see the loadings have been done. So what we have done is we haven't changed it into this unique, so just do this back as unique, because this is an important step, and because of the terrace we'll have different kinds of loads. So just to correct this error, you can just go to this particular structure and open the terrace portion. So, and just to go to the 3D view of it, turn on the particular dead loads, because the dead loads are the one which we need to change here. If you can select the loads here, if you can select the load items, and let's try the delete option. Loads are selected, and again just select this, select or select the entire structure, and then if you just click on delete, we'll just untick everything except the load part, and then delete the loads. So after the loads are deleted, we can just go to this imposed load. We have already assigned to the same, don't need to worry about that. A dead load, we'll just change here. So we'll go to this particular option of loading, this full UDL 2 kilonewton, let's give for the terrace portion, 2 kilonewton here, along here, along this small span as well, and along this span. So this span we need to just take care of. This span, this, this and this. Now there will be a particular load of 11, or there will be UDL of 2 kN from here to here, and there will be UDL of your 11 kilonewton from just need to pick your point here, and can need to go to UDL here and then check your point from where you want to assign. Let's give it up to here, and then again just click here and can go to full UDL, and if you apply the full UDL, it will be from here to here. Go to UDL and then pick this point and up to this point, UDL, pick this point and up to this point. We have applied all the loads here, as you can see here. Now we can go to the structure 3D view and then check the loadings here, the dead load, as you can see, and the imposed load. So we have applied the dead load and the imposed load, and for modeling and loading of the dead load and the imposed load are complete. Now if you want to assign some wind panels, you can do that. Validation, check the validation is okay. We'll go to model, and then we'll go to the wall panels, and the wall panels, let's apply some wind panels here, and we'll start from the plinth level, and we'll rotate the model here, start from here to here to here, and the last we made some error. We'll just click on escape and start again. This, and after that this, select this, select this, and select this. After that, this one part is remaining, select this, and this, and this, and this. So this, all the modeling part has been completed, and after that we'll go to loads, and then we'll generate some wind wizard, and we'll consider worst case data. This we am going with the IS 875 part 3 orientation. Let's give this 90, and basic wind speed 50, and then next this edge distance of 5 meters, and then let's click on finish. Then we'll take this particular, add 4 directions, 0 degree, 90 degree, 180 degree, and 270 degrees, and then OK. And then we go to seismic load, seismic wizard. We'll just go with the code spectra, ignore below the base level or the plinth level, and then this particular importance factor of 1 for the residential building, and then model response spectrum analysis here, and then RC moment resisting frames will select, and then ordinary moment resisting frame or the moment frame systems will select here. Next, take the consideration live loads and the dead loads. Finish some load combinations for the seismic load. Operating, next, finish, generate the load combinations, generate, include the limit state combinations, and then next, finish, OK, and then go to your particular design, and then design all static. So like this, the design steps of the Tekla Structural Designer will be completed.